Alright, in this section, we'll build on top of what we covered in the previous section, and by the end of this, you should be able to build this search tool. You can use embeddings, keywords, and even SQL to search through your database. In this one, we'll introduce a new concept, which is keyword-based search or full-text search, which I'll cover in slight depth in the next section, but here we'll just take a look at an overview. So let's take a look at an example. You can search through embeddings, which is these text, whatever you type in will be converted to embeddings by using clip model, and then these models will these embeddings will then be sort of projected out in the search space, and you'll find the closest images to these texts, right? So I'll just give you an example. I can say portrait of a person, and then it should give you the code to do that in Python. In the first cell, in the second cell, you'll find these things, right? And I'm not sure how many classes are there in this database, so I'll just say maybe books, because I saw some of them. And so yeah, the data set here, what it does is it sort of disfigures the face of real people, but not the portrait, so just for preserving the privacy, I guess. Yeah, you can see all the faces are sort of jumbled up. So what we'll do now is we can do keyword search, which is if there was a keyword column in our database, we could search through that as well. This is full text search. I can show you some more examples of it. Maybe I'm not sure if there's a person in the database, but let's just search through it. Yeah, so this is searching through metadata. It's not actually running this through a model and getting embeddings. And then finally, you can also search through SQL through your metadata, which is we only want to select images from DiffusionDB database, which is the name of this, and I'll cover this, where the image is NSFW, and limit that to 9. So we should get 9 images that are sort of blurred out, right? So this is what you're going to build. So your embeddings, we have already covered it in the previous section. SQL, we'll cover it. We don't really need to cover it. You know what SQL is, but how you can use LanceDB to sort of run SQL queries, we can cover it, which is just one line of code. And then keywords is one that I want to cover. So keywords essentially is full text search here. So if I do person, so you see table.search, which we have seen in the previous section. Here you should pass an embedding, but here we're passing a string. So this string essentially is not using string matching directly. You're not using string search. You're essentially using full text search. And what full text search is, let me just quickly introduce you. So the types of search is string searches like this that we are used to. So it will search each and every character of the string and run it through the entire knowledge base, word by word or character by character, until it finds the right document or text. This is really slow as it scales, right? It's not really good. There's a lot of research done in this direction as well. You can read some text, but it's not worth doing for millions and billions of documents. Full text search is a way to index these documents by their keywords, right? So what happens is essentially you will have a dictionary or an index of this each keyword stored with in what documents, mapped within what documents they appear, right? So a simple example of this would be, you get an original text for just like you do with NLP. You sort of process the text to remove all of the things that are not necessary, right? So diacritics have been removed, and then process filter words. So filter words such as with, the, and, all the articles have been removed, and then you stem those from the sides, and then you just make sure that the casing is the same. So you just reduce the variation on the same meaning or the same word, and then you essentially map them in dictionary. So each index will contain a word and the document in which those words occur, right? And this is a way to sort of use space and then trade it off with search time, right? So we want to reduce the search time, but it comes at a cost of some space, right? This is what full text search essentially does. And there's a lot of algorithms which and a lot of optimizations that I'm not covering here. It's essentially give you an idea of what full text search is and that it's available, and that's what we're going to do. So this is what we're going to build. Now let's look at the code, right? So let me just get rid of all of this. All right, so this is in Colab. You can just follow along. You might have some difficulty in installing TentIV, which I might have something in the description for it. On Colab, I was facing some problems, but yeah, I will confirm that and add it in the description. But the link to this code and the repository is also in the description. Do visit that and give us a star if you enjoy it, right? So first step is to install the libraries that we need. Second step is to import them. And the third step is to get this DiffusionDB LANS file format that we have publicly available. So you just download it, you extract it, and move the DiffusionDB test in the database folder. This is just a step that you don't need to worry about. It's just the way it's been organized. We can not worry about this, right? Once you do that step, you have a LANSDB table that can be converted into a LANS file format that can be converted into LANSDB file format. So we'll just create a new database that we've already seen. All of this we have already covered in the previous section that you can see. So if DiffusionDB exists in our table, we will just open that. If it doesn't exist, we'll use the file that we have downloaded to convert that to the table, right? And then the last thing that we do here is we create an FTS index. So creating FTS index essentially means doing this. So this will take some time, a few minutes, if you're doing it for the first time. After that, it should not take any time, right? So the next thing you do is we essentially want to initialize our models, which is Hugging Face clip. Again, we've covered that in the previous section. It's a multimodal model so that you can represent text and images in the same embedding space, maintaining the semantic meaning and relationship, right? So that's the next step. We'll create a tokenizer model preprocessor. All of this is used in modeling steps. And the next part is to basically create an embedding function. It takes a query and then tokenizes that, and then this takes text, by the way. So this converts them into embeddings and then essentially returns those embeddings, right? That's pretty much what we are doing here. So that is that. And so let's just look at what the table looks like. So here's the table, right? Here's the table, or better, we should just look at the schema. So I'll just take a look at the schema. We have the prompt, which is the string. We have a seed, step, configuration, sampler. We are not going to be using all of this. Width and height is the image property. Timestamp is when it's taken. And then let me just print that again so that by the time it prints up, we also have the example ready. And yeah, so it should take a few seconds because it is a large data set, and I have also messed up my memory, I guess. Anyway, yeah, so this is the timestamp, and then the level of NSFW, which is if the image is safe for work or not, and then the prompt NSFW, which is the prompt is safe for work or not, and then the image itself in binary format, right? Okay, what we'll do now is we'll just build these three search bars that you saw, right? So first is find image by vectors. So essentially we'll get a query, which is a string. We'll convert that into embeddings by using the embedding function, and then we will, because the second part of the GUI contains the piece where you get the code from. So if we have this code essentially of how to use the table, it's not really important for this, but it's just for reproducibility of those GUI results. And then you just run the search function, and then you run the search on this embedding, limit that to 9, and then convert that to data frame, right? So that is pretty much it. And then this extract function essentially takes a data frame, and then it returns the pillow images. So it essentially takes the bytes, because we've stored the images in bytes, opens them using pillow, so that it is sort of readable by this Python code, right? That Gradio needs. The second thing is essentially the search where full text full text search index. So we'll do the same thing here. Instead of passing in the embeddings, we'll just pass the search string. We are assuming it's going to be string, and find using SQL query. SQL query can be executed on LansDB tables using DuckDB integration, right? So you just simply open the table, and then you convert that to Lans file format, and Lans is integrated with DuckDB, so you can just say DuckDB.SQL query, and then pass in that query using this particular diffusion DB, because that is integrated well into that. And so now you have you can execute SQL in using LansDB, right? And then convert that to data frame and use the same extract function to get it, right? That's exactly what you're going to do. And now we have all the functions. We just build the Gradio interface. So we have blocks, which is the top level. Think of this as the div in HTML, and then row. So this is the first row, right? So first row essentially is the search button, right? And then it has 3 tabs. So tab number 1 is embeddings, where the vector query by default is this in a text box, and a submit button essentially will submit it, right? And then the second one is keywords, third one is the SQL tab, and these are all the default values of these, right? And then the code essentially is the second one here. Let me go back here. So we covered all these 3, and then the second one is essentially submit button. Sorry, it's the first one. The second one is code, and then finally we come to the third one, which is the gallery. Gallery essentially is a mosaic of images if you're coming from React or some front-end development. So that is what gallery is, and it just fills them up by default with the default images, right? So once someone clicks, we just now assign them with actions. So it's like what happens when user clicks it. So button.click is find image vectors, and then inputs is vector query, this, and then the output is gallery and code. So essentially these two will be filled up with the when you click this button. Similarly for other two, right? And that's it. We just open it up, you get your search engine. So now you've actually covered a lot of ground in what similarity search does, what you can do with LansDB, how easy it is to set it up, and we'll cover one more example where you will build a recommender system or a search engine for archive papers. So for example, if you're reading something on a topic such as self-supervised learning, you're like, well, I would like to read something more like that. You just search through the abstract. It's what is covered in the paper, and it will recommend you the best papers out there about that topic. So it's like a very simple thing, but then it can be used to build something more efficient, something more useful, which is like, building a curriculum based off where you are, what you're reading, and where you'd like to go, and can just connect things together, right? That's just an idea, just to get you excited, and see you in the next section.